On the set of positive integers, the factorial of n is defined as follows. It is the product of all positive integers from 1 to n. In particular, this product is the factorial of n minus 1. Then the following recurrence relation is true for the factorial. Well, as for 0, its factorial is equal to 1. Mathematicians simply agreed on this, and that's it. It can be the end of this video, but I would like to demonstrate that such an agreement does not lead to contradictions. Well, really, what is the factorial of 1 according to this formula? It is equal to this. But then 1 factorial is equal to 1 times 0 factorial. This means that 0 factorial is equal to 1 factorial over 1. But 1 factorial is 1, so 0 factorial is equal to 1 as was agreed. We can go even further and remember that the concept of factorial can be expanded beyond positive integers using so-called gamma function. That is such a function. Then the following equality will be true for the positive integers n. Now let's calculate the value of the gamma function for n equals to 1. On the one hand, this is 1 minus 1, that is 0 factorial. And on the other hand, this is a such integral. But t to the 0 power is simply 1, which can be omitted. So we integrate the function e to the minus t power over dt. This is minus e to the minus t power within the range from 0 to infinity. Let's swap the integral limits and remove the minus sign at the beginning. If t is equal to 0, then e to the 0 power is equal to 1. If t tends to infinity, then the value of the decreasing exponent tends to 0. As a result, according to the Newton-Leibniz formula, we get that the value of this integral is equal to 1, and again, as was agreed. So there are no contradictions here. That's all for today. Thank you for watching and for your donations.